inverse trigonometric functions. So the value of sine of 2 sine inverse cosine A is blank. Options are sine A, cosine A, cosine 2A, sine 2A. So now sine of 2 sine inverse cosine A. So can we write like this? Sine of 2 sine inverse, and this cosine A is in terms of sine. So that is a sine of pi by 2 minus A. Sine of pi by 2 minus A is cosine A. So this is equal to sine of 2. Now sine inverse sine pi by 2 minus A. So this is pi by 2 minus A. And so this one is sine of pi minus 2A and pi minus. So it is in the second quadrant, and second quadrant sign is positive. So that is sine 2A. So the answer is sine 2A. Okay. Let us solve one more. Sine inverse of minus tan of 13 pi by 8 equal to blank. Options are minus 5 pi by 8, 3 pi by 8, minus 3 pi by 8, and 13 pi by 8. Okay, we solve this. It is this is not sine inverse, but it is tan inverse. Okay. Now we have the formula for tan inverse minus tan 13 pi by 8. So we know the formula tan inverse minus x equal to minus tan inverse x. So this is equal to minus tan inverse tan of 13 pi by 8. Now this one is minus tan inverse. Now this 13 pi by 8 is not in the interval minus pi by 2 to pi by 2. So we need to make the adjustment, and that is not difficult. This is the tan of, can we write like this, 2 pi minus 3 pi by 8. Okay, and tan of 2 pi minus, so that is in the fourth quadrant, and tan is negative. Okay, so minus tan inverse minus tan of 3 pi by 8, and again we use the formula. So tan inverse tan of 3 pi by 8, and so that is 3 pi by 8. 3 pi by 8 belongs to open interval minus pi by 2 to pi by 2. So the answer is 3 pi by 8. So this B option is there. Okay, let us take one more. Sine inverse sine 32 pi by 7 is blank. Options are 3 pi by 7, then 4 pi by 7, then 18 pi by 7, and then 32 pi by 7. Okay, so sine inverse sine 32 pi by 7. Now 32 pi by 7 is not in the interval minus pi by 2 to pi by 2 close interval. So again we need to adjust this. So sine inverse sine, now can we write 7 5s are 35. So 5 pi minus 3 pi by 7. Okay, and 5 pi. So here there is a 5 pi and minus. So it is in the second quadrant. So sine inverse sine 3 pi by 7, and so this is nothing but 3 pi by 7, because 3 pi by 7 is in close interval minus pi by 2 to pi by 2. So the answer is option A. Okay, next, the value of cosine pi by 6 plus cosine inverse minus 1 by 2 is blank. Options are minus root 3 by 2, root 3 minus 1 over 2 root 2, root 5 minus 1 over 4, and this is root 3 plus 1 over 2 root 2. So let us solve this. It is cosine pi by 6 plus cosine inverse minus 1 by 2. Now cosine inverse minus x is pi minus cosine inverse x. So this is cosine of pi by 6 plus pi minus cosine inverse 1 by 2. So this is equal to cosine of pi by 6 plus pi and minus cosine inverse 1 by 2. So cosine pi by 3 1 by 2. So that is pi by 3. And so we can now simplify this as, so 6 pi, 6 pi, this is minus 2 pi. So cosine 5 pi by 6 and cosine 5 pi by 6 is cosine pi minus pi by 6, and second quadrant pi minus cosine negative. So this is minus cosine pi by 6 and value is minus root 3 by 2. So the answer is A. Okay. Let us take one. Tan inverse 2 plus tan inverse 3 is blank. Options are minus pi by 4, pi by 2, 3 pi by 4, 3 pi by 2. So let us solve this. Tan inverse 2 plus tan inverse 3. Now we know tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy if the product xy is greater than 1. Now here the product 2 into 3 is greater than 1. So this is pi plus tan inverse 2 plus 3 over 1 minus 2 into 3. So this is equal to pi plus tan inverse phi upon minus phi. So pi plus tan inverse minus 1. So this is pi minus tan inverse 1. So this is pi minus pi by 4. And so this is 3 pi by 4. So the option is this C. Okay, let us take the value of sine of tan inverse minus root 3 plus cos inverse minus root 3 by 2 is blank. Options are minus 1, 0, 1 by 2, 1. So let us see now. Sine of tan inverse minus root 3 plus cos inverse minus root 3 by 2 equal to sine of, now tan inverse minus x is minus tan inverse x. So minus tan inverse root 3 and cos inverse minus x is pi minus cos inverse x. So pi minus cos inverse root 3 by 2. So now we know tan pi by 3 is root 3. So this is minus pi by 3 plus pi, and cos pi by 6 is root 3 by 2. So this is minus pi by 6. Tan pi by 3 is root 3 and cos pi by 6 is root 3 by 2. So this is equal to, now you can simplify this. So this is 6 minus 2 pi plus 6 pi minus pi, and so this is nothing but sine of pi by 2, and so that is nothing but 1. So the answer is 1 here, D option. Okay, next let us see. Sine inverse 3 by 5 plus tan inverse 1 by 7 is blank. Options are pi by 4, pi by 2, pi, sine inverse 4 by 5. So now let us see. Sine inverse 3 by 5 plus tan inverse 1 by 7. Now this is sine inverse 3 by 5. So we can have, this is sine inverse angle and 3 by 5. So this is 3, 5 here, and so it is 4, Pythagorean triplet. So that sine inverse 3 by 5 we can write as tan inverse 3 by 4 plus this is tan inverse 1 by 7, and we know that tan inverse x plus tan inverse y equal to tan inverse x plus y over 1 minus xy if the product xy less than 1, and here the product 3 by 4, 1 by 7 less than 1. So this is tan inverse 3 by 4 plus 1 by 7, 1 minus 3 by 4, 1 by 7, and so this is equal to tan inverse, this is a 21 plus 4, 7 4s are 28, and it is here. So 28 minus 3. So this is tan inverse 25 upon 25, and so tan inverse 1, and so it is pi by 4. So option A is the answer. Okay, now let us take one more example. The value of tan of cosine inverse 3 by 4 plus sine inverse 3 by 4 minus sec inverse 3 is blank. Options are 1 by root 2, then 1 by root 3, 1 over 2 root 3, 1 over 2 root 2. So now this is tan of cosine inverse 3 by 4 plus sine inverse 3 by 4 minus sec inverse 3. But this we know, cosine inverse 3 by 4 plus sine inverse 3 by 4 is pi by 2. So this is pi by tan of pi by 2 minus, now this we can write as sec inverse 3 as cosine inverse 1 by 3. Okay, and again we can use that sine inverse x plus cosine inverse x is pi by 2. So pi by 2 minus cosine inverse x is sine inverse x. So this is tan of sine inverse 1 by 3, and this sine inverse 1 by 3 we can write as sine inverse angle. So this is 1, this is 3, and this part is root 9 minus 1. So it is 2 root 2. Okay, and so this is equal to tan of tan inverse 1 upon 2 root 2, and so the answer is 1 over 2 root 2. So this option D is there. Okay, next let us see the value of sec of tan inverse b plus a over b minus a minus tan inverse a by b is blank. Options are 1 root 2, 2 and 4. So now let us see sec of tan inverse b plus a over b minus a minus tan inverse a by b equal to sec of tan inverse, now tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. So this is tan inverse b plus a over b minus a minus a by b over 1 plus b plus a over b minus a into a by b. Okay, So now this is equal to sec of tan inverse. Now we can simplify. So this b minus a into b, you can take it LCM. So b multiply here and b minus a multiply here. So that is b square plus ab minus ab and minus minus plus a square. And similarly here b square minus ab plus, now this is a b plus a, so we need to multiply. You are having like this. Okay, so this a is multiply here, a is multiply here, so plus ab and plus a square. And so this is equal to sec of tan inverse. Now what? This is a square plus b square over a square plus b square, so it is tan inverse 1. So tan inverse 1 is pi by 4. So this is sec of pi by 4, and sec pi by 4 is root 2. So the answer is root 2. Okay, let us take one more. The value of cot of pi by 4 minus 2 cot inverse 3 is blank. Options are 3, 7, 9, 3 by 4. Now cot of pi by 4 minus 2 cot inverse 3. So this we can write as cot of. Now let us do like this, convert into say tan. So if I consider this cot and tan, so tan of pi by 2 minus theta is cot theta. So I can write this as tan of pi by 2 minus pi by 4 minus 2 cot inverse 3, like this. So this is equal to tan of pi by 2 minus pi by 4 plus 2, now cot inverse 3. We can write as tan inverse 1 by 3. So tan inverse 1 by 3. So this is equal to tan of, now pi by 2 minus pi by 4, so it is pi by 4 plus 2 tan inverse 1 by 3. Now see, we know that 2 tan inverse x is equal to tan inverse 2x over 1 minus x square. So this is equal to tan of pi by 4 plus tan inverse 2 1 by 3 1 minus 1 by 9. Okay, so this is equal to tan of pi by 4 plus tan inverse. Now this is a 2 into 9 over 3, and this is 9 minus 1, 8. Okay, so tan of pi by 4 plus tan inverse, now this is 3, this is a 4, so this is 3 by 4. And now we know tan of alpha plus beta is equal to tan alpha plus tan beta over 1 minus tan alpha tan beta. So tan pi by 4 plus tan of tan inverse 3 by 4 over 1 minus tan pi by 4 tan of tan inverse 3 by 4. This is 1 plus 3 by 4 over 1 minus 3 by 4. And so this is 7 by 1. So that is nothing but 7. So the answer is 7. Okay, thank you.